Hi there guys, old man Chris here, still with his remains of his cold. I feel like I should be talking like I got a cold in the head, and it's like you're all sort of bugged up and you can't say your words properly. It's probably intelligible, but it still ain't gone. Anyway, bit of an intro. Slightly odd or different video this time, partly because I found some old photographs, which is what prompted me to do this. Prior to that, I'll oh, hang on a minute. Oh, excuse me, sniff. Just before I launch into that, the sash clamp lead screw, which I showed one or two videos ago, on which I intend to make a replacement. I chickened out of bothering to grind a tool specially for an ACME, and I found, well, this won't convey bugger all. In this little holder here, it's a double-ended insert for a 12 TPI ACME, which I happened to find it on eBay. I thought, oh damn it, I'll get that and make use of it somehow. Whether it'll be quicker than grinding an HSS tool, I don't know, because I'm going to have to make a tool holder. Being double-ended, I really ought to make a holder that retains it so I can use both ends. But to be honest, I'm not going to be using it for many threading operations, I don't think. So what I might do is find a piece of material and mill out a 5mm slot and braze this thing in so I can use it. Anyway, enough of that, we'll come to that another time. So these pictures. For a long time since been talking shop. I mean, you've seen the mess that I exist in here, but I couldn't previously find any pics of the old shop. Well, I found a couple of pics of that, which I'll throw in and describe. Also, there was a pic of my old Myford. Anybody who's seen my channel page will see a rather wide, not very high pic also of the Myford. This Myford pic is, it's a vertical orientation, but I've actually cut it into 3 chunks just for interest's sake. The top part shows my homemade 4-way tool post. The second shows where I fitted a homemade indicator dial, and the most important part was the bottom picture, where I made a reversing gear with a block fixed to the apron to make the thing go the right way, which I refer to. But you would normally, if you turn your saddle wheel that way, you would expect the saddle to go that way with it, and if you turn that way, you go to the same direction towards the chuck. Anyway, this old Myford, I'm not sure quite what version it was. Somebody may know, it's academic. But anyway, I showed that. It was using a block with some gears, made it work the right way around. Anyway, the main otherwise interest pictures were 2 pictures of my old clutch setup on the Myford, and I'd forgotten I had those pics, and they show it fairly well. Now, many months ago, if not couple of years ago, in one of my odds and ends videos, I showed a drawing of this clutch, and at that time it was all I had to describe. I've got the video clip that I made. It's not very good, and the vocal description was done at the time, and I haven't put another soundtrack on it. I've just thrown it in to support the photos. But somebody asked me quite a long time ago, you know, how did you make your clutch assembly? And this is why I'm making the video. The photographs I mentioned, I think I'd made with a fairly early digital camera. They're pretty crappy, but maybe adequate. I've put a voiceover on the pictures, and at the moment I'm not sure, when I construct or do the editing, whether I'll put the video of the drawings first or after. Really not sure. So it'll be what it is, and I'll probably put a brief ending on the video, alright? And yes, that's enough ramble. Let's get on with it. Alright, I'll see you at the back end, I hope. Well, here's a pic of the old shop, probably about 20 years ago, I should think. I had a solid floor, but it was all over the place, so all the machines were on concrete plinths. You can see the chaos is about normal for me. Not one of my better days there. Drill press on the right, on the left, if you can read the letters anyway, there's the Raglan lathe, which I've kept, and then the old Myford, beyond that the horizontal mill, and beyond that the old shaper. Those two I miss greatly. I had a lot of space in this shop, but of course used it all. The old barn again, looking the other direction. Pretty chaotic, as I said. On the left, you won't be able to make half of this stuff out. There's a power hacksaw, small surface grinder, which I really wish I'd never got rid of. Down the end on the left is the drill press on the bench, and then on the right hand side you can see the box and clapper on the shaper. Horizontal mill. I think there's a load of stuff dumped on it at the moment by the look of it. Then the old Myford and the Raglan Little John, and beyond that my gas cylinders for welding. So that gives you some idea. Having found these pictures, I thought I might as well show you. Now this pic won't show up terribly well, I don't think, but I'm throwing it in because I'm going to split it into three in a minute. The top there is a four-way tool post I made for the Myford. The compound has got a graduated dial on it, and the main thing I was going to show was down the bottom. You'll see a gear block, and this was made to reverse the travel, which I'll cover in a minute. This was the four-way tool post on the Myford. Just a closer look. It's made all the difference having that instead of the original. I may have mentioned before anyway, the camera I used back then was absolute crap. It was an early digital, so definition isn't very good, I'm afraid. This is the middle of that other picture. The scale that is on the compound, that was made, it was engraved using my divide by 100 dividing setup that I can use in the spindle of the Raglan lathe. It's rather fine etching, so you won't see it on the picture. A closer look here at the gear block. The weird thing about this Myford, and I'm not actually sure technically what model it was, but if you turn the handle to move the saddle, if you went clockwise, the saddle went towards the chuck, and vice versa. I've no idea why it was like that. So anyway, just cutting it to size, bolted a block onto the side of the apron casting and ran a small gear between the handle and the casting, then a larger one, shaft through the block to a small one to travel on the rack, and this then made it go the right direction. Very weird. It was impossible to use for me before I did that modification. I'll try and describe this carefully. You may actually well pause the video and take a look at the annotations I've added. It's only since finding this picture and the following one that I thought I would run through this, because quite some time back somebody actually asked me about the clutch because I'd referred to it, and I did actually a long time ago. I did a video on showing the drawing. I found that clip and I'll put it in afterwards, because it may be, if somebody's interested in making something similar, it might give them some ideas. So working from the left, there's a triple flat belt pulley which is set up the reverse of the machine pulley, so we've got 3 speeds. The whole shaft is set between plain bearings. We used to call them plumber blocks, and I was fortunate to have quite a bit of aluminum to play with when I made this, and I think I made this in about 1992, somewhere like that, maybe even earlier. So I made the large pulley first, and then I made the block to the left of it, which has a taper turned on it lined with cork, and the inside of the largest size triple flat belt pulley was bored to the same taper. Forget what it was, I'm guessing it was probably 15 degree. And then to the right of the pulley there is a fork assembly, and you can see a bolt on the lowest part on this side which holds a small bearing race. So the fork impinges on a thrust plate. To the right of that is a pretty hefty spring, and on top the fork unit is attached to a sliding bar which is attached to a sub plate, and that's moved by the grey coloured operating lever. And you might notice in the front there's a ratchet. It's a ratchet and pull basically, so that when the clutch is disengaged, the ratchet connects on the pawl and holds it out of engagement. And in the next picture you may just be able to see the way I operated that to re-engage. The motor is extremely old, like a lot of my motors were back then, but it actually worked alright. This is a view more or less from the other side of the clutch unit, and we've got the same basic annotations, except I've noticed a typo, not to worry. So from the right we've got the plumber bearing block, triple pulley, drive belt, then the cork liner on the taper. That large boss is bolted to the pulley, which is a regular V-belt. I just used the what was called in the UK picker link. Most people know that system. Then we've got the rear boss for the pulley unit, then the fork unit, thrust plate, spring, and through the whole lot of course is the shaft, which I think was probably about an inch, more than likely. And the actuating bar is slotted, which should be evident on this picture. And then on the underneath that the base plate. And at the end of the operating lever, the grey thing, you might make out it's actually a piece of welding rod running in some brass tube, and it's used to actuate the ratchet release. Clutch worked extremely well, and I'm glad I found these pictures now actually, because if you relate the information on these to the drawings, and I'll put the clip in to follow this to describe the some of the details, the drawing might actually help to make it clearer.
Now, before I left the UK in 2000, I got rid of a lot of machinery, and one item was Myford 3.5 inch, and one of the biggest modifications I did to it was making a clutch assembly, and this is partly visible in one of the rather poor pictures I have of it. And in essence what we've got is a drive. Let's start from the left. This is the plan view. That's one end of the main shaft, which is a phosphor bronze, what we used to call a plumber block. And here we've got stepped flat belt pulley going to the lathe. Here is the main drive pulley from the motor, and what we have, if you can see the dotted line here, this is all made out of aluminum, all this area. We've got a tapered section here which goes inside the flat belt pulley here, which was also machined to a taper inside, and the section drawing will show things a bit better in a moment. And then here we've got a fork assembly. Somewhere in here is a spring too, I don't think it's showing. And this part on the side here is a sliding linkage for engaging and disengaging via this lever here. That's a pivot point. So that goes this way or that way. If it goes to the right, it moves this out of engagement against spring pressure, and there's a locking facility on the lever there. That basically is... Oh, and we've got a ratchet, by the way. There's a ratchet here which is there's a little detent here, and that holds it out of engagement. So to engage we have to actually just release that little pawl. Let's move the camera now. Alrighty, now the section, this helps a little bit more. So again we've got plumber block. You won't see, I don't think, just off, hang on, let's see if it's on the picture. No, it's not quite on the picture. These two lines show the angle 15 degrees. So there's the plumber block, there is the flat belt pulley, machined inside to 15 degrees. The whole of this block, which actually was made up, the pulley and another block were made separate and joined. There's a thin layer of leather adhering to the inside of this, so you've got, it's a cone clutch, that's the easiest description. There's the pulley for the drive from the motor. There's a bearing and another bearing. Then we've got the forks. The forks work within this section here, so this is, if you like, this is like a thrust collar, thrust block, and then the fork is actuated by the this piece of bar here, which has a handle on it. So when the fork is taken to the right, we disengage the taper of the clutch and the drive no longer goes to the lathe. And then finally, if we can set the camera over just a bit, alright, this is on the left of the plan drawing. This is an end view. So what you're looking at here is the main drive pulley. There you've got the forks, main shaft, there's a bearing, and I'm just trying to see whether this shows very clearly because you're looking end on, so this doesn't show you a whole lot other than the fact that this is the fork unit that will pull the clutch out of engagement. Alright, just a little explanation on that and see if it shows up adequately. Just to give some idea of what was involved. It was a very interesting project and a lot of work, but in the end it did a good job, and I think the guy who bought the lathe in the end did alright out of it. There was one other modification on that lathe which I'll probably mention when I show the photograph.
Well, there it is. The drawing video clip, as I mentioned, it's not very good. It was done a long time ago. I think it was on an earlier camera, so generally not very good. I've tried to boost it a bit, but maybe it's enough to help. So overall it'll give you some idea of how the clutch was put together, and the other bits preceding it, well, just a bit of interest, and as you could probably see, the old shop was a pretty definite state of chaos. Alright, the one thing I'll do just before I finish at the end here, I'll just show the ACME insert that I referred to, just in case anybody knows of a ready-made holder for it. It's a slightly odd design from the point of view of retaining it in a holder, so I'll throw that in just in case anybody's got any thoughts on it. Failing that, I shall just make something and braze it in. Here's this ACME insert. You see it has a diagonal sort of V slot, same underneath, it's a mirror image, but I'm not sure quite what holder would actually take this, if there's one commercially available. And there's the cutting edge. Anyway, just throw that in case anybody's come across it before. So there we go. Thanks for watching, guys. Thanks to all the subscribers, and see you in the near future, all being well. Bye for now.